daily content on piezoelectric and ultrasonic device characterization, analysis, prototyping, and development. So today I'm going to be speaking about how can you reduce the variability of piezoelectric materials. Anyone who's worked with piezoelectric materials knows that their devices that you create with them are often have variable performance. And if you've done any amount of material characterization, whether you get like a disc sample, something a little dude like this, and you analyze 10 of them, you're going to be finding a significant amount of variation. And when you go and you order another lot from your manufacturer, you will also get an additional amount of variation. So manufacturers may even support or cite a plus or minus 20% tolerance. That could be 40% from top to bottom. That would be permissible for something that would be quote unquote in spec for your application. Now, as a company developing ultrasonic devices, this maybe you won't see all of this variability all at once, when you're getting the first few lots, but over years there may be certain changes in the supply chain of those devices. And I actually explain why piezoelectric materials are so variable in their properties, and that's in the top three in my guide to the top 3 challenges in the development of ultrasonic transducers, and I'll have a link to that in the description here, and that'll also sign you up for my email list, and as well as you'll get daily updates on these videos, as well as the transcripts, which you can skim over at your leisure. So I want to give one lesson in how we can reduce variability in piezoelectric materials and ultrasonic devices. One simple way to do that. And I want you to take a lesson here from Starbucks. So why are we taking a lesson from Starbucks in terms of reducing variability in ultrasonic devices? So when I go to Starbucks, oftentimes I get a drink which is called the vanilla sweet cream cold brew. All right, so it's cold brew, and there's like something called sweet cream, which I guess adds some sugar and adds some milk. But the issue here is whenever I order this drink, it comes out different every time. Now, I know there's probably some type of set directions on how to make it, just like the manufacturer of your piezo material is going to have the same direction, the same format about how they make their ceramic every time. However, the end result is different. And sometimes if it's too different, you ask for a remake. That may be something that's, out of tolerance, for example. You specified a tolerance, the manufacturer said okay, but they may actually end up producing sometimes out of tolerance parts. So that's fine. But in order to have an acceptable tolerance range, when you're trying to, plus or minus 20% for most devices is way too much. We have other ways of controlling this, which include calibration. But another way that you can very easily control the variability of your drink at Starbucks, assuming it's a cold drink, as well as the variability of ceramics, is this fact. The fact that you often use more than one ceramic in your device. All right, so you often use more than one ceramic in your device. So if you measure your properties of your ceramic, you have, for example, you either use capacitance as a metric or the electromechanical coupling factor as a metric for the performance of your piezo, you can stick a high and a low value together and end up effectively getting something in between, so therefore reducing the variability, especially of the outliers. That you'll have some materials with a very high coupling, and you'll have some with a pretty low, and you're able to kind of center those two distributions and reduce the tolerance a lot. So how does this refer to Starbucks? Well, if you ask them nowadays to remake your drink, like let's say, oh, it didn't have enough cream in it, right? If you ask them to redo the drink, what nowadays, because of COVID protocols, they're going to just make you a new one. And when they make you a new drink, it will have too much cream. If you said it didn't have enough, then when you make it again, it'll have too much. So what do you do then? Well, this is what you do. So you ask for too much, that they give you. So now you have one that they're not going to throw away. So they just let you keep that one with not enough sweet cream, and then they give you one with too much sweet cream. So what you do is you ask for another cup. Let's say, can you please remake this drink with more sweet cream? And you also ask, can I also have a venti cup as well, an empty venti cup? Okay, fine. So once you get that together, then you pour the 2-in-1, and now you have a drink twice the size, but you also have your perfect blend as well. So you not only do you not have to waste that first drink, you actually get twice as much in the end. So this is the same thing that you got to do with your piezo. So if you have an application which is especially having challenges with variability, think about using 2 piezos in your device. That can be a means of reducing variability, at least caused from the ceramic. Now, there's other causes for variability which can be addressed from the circuit drive perspective. There's an algorithm or firmware aspect to it, or just the construct and the function of the build of the device in general, and other components can cause variability. But at least as far as you're starting off with trying to get your piezo ceramics correct, I recommend using the Starbucks method and mixing your drinks together, or mixing your piezos together, therefore reducing that large curve or that large variation in your ceramics to something that you can work with. Thanks for watching this video. You have just watched the 7th episode of The Shock Show. I appreciate you sharing these videos across your network to any of your colleagues who may benefit from it. Also, look in the description for a link to my blog where I post updates of these videos, so you can sign up for my email list. You'll also get the top 3 challenges of ultrasonic transducer development. Thank you for watching. See you tomorrow.